Hello, this is Professor Urbis-White. Today we will talk about two variable inequalities, variable x and y. And this is intermediate algebra level, so we are only going to do linear systems, lines, so no curves in there. Okay, what's the general procedure? Ignore the smaller, greater, smaller than, greater than at the beginning and draw the lines. Those are your boundary lines. Then shade the regions and then test using test points. I would start with 0, 0. And then if 0, 0 is on top of the line, you cannot use that one. Use something like 0, 1 or 1, 0. Look at the overlap. And if there is nothing in there in terms of and or, you always assume it's an and when you're talking about a system. If they want or, they will tell you it's an or. Double check and see your answer makes sense or not, and you're done. Okay, now, like I said, there's nothing between these two, so that implies that there is an and. Okay? If there was an or, they would have told you. X is less than 2. How does that work? 1, 2. X is less than 2. Here's my 2. I'm going to make it dotted to start with because I do not have an equal. If it is an equal, I do it solid line. Now I'm going to check. Let's check my 0, 0. So 0, 0 means this is my x coordinate and this is my y coordinate. So I'm going to plug it back in there and check. X is less than 2. Here's 0 is less than 2. Is that true? True. Then you shade the region that includes, when it is a true statement, you shade the region that includes that point, that test point. In this case, it's going to be here. Now we go to the next one. Y is greater than or equal to 5. 1, 2, 3, 4, 5. And that one has an equal. So it's a solid line. Now I'm going to check the test point 0, 0 again. So my inequality was y is greater than or equal to 5. And what is y? In this case, it's 0. 0 is greater than or equal to 5. Does that make any sense? No. So since it does not make sense, you have to shade the opposite region on the other side of the line. Now, since it is an and statement, I need to look at the overlap. Can you see the overlap? I extend a little bit. So my overlap is where orange and blue are overlapping, and that happens to be this region. What is the meaning of shading? The meaning of shading is, that means any point that I take on this thing is going to satisfy this equation and that equation, that inequality. So that's what shading means. Everything in that region is included. Very good. So let's do this example. X plus y is less than or equal to 4. Now, to be able to do this problem, I need to put it in slope-intercept form. Y equals negative x plus 4. So I ignore this equal sign. So let's do that. I'll just go over how you draw those lines. You start with the y-intercept, which is 1, 2, 3, 4. You put a dot there. You look at your slope, which is negative 1. Put a positive 1 underneath so that you can do the rise over run deal. This one is the same as negative 1 over positive 1, right? So negative 1 means you're going to go down. Positive 1 means you're going to go to the right. And what you're going to do is you're going to connect these two lines. And since it's equal, so it's going to be a solid line. Now I'm going to do the shading for this line. Here's L1. Now I'm going to take a test point of 0, 0. That's xy. Now I'm going to test. So 0 plus 0, is that less than or equal to 4? Yes, it is. So what am I going to do? So this one is, the L1 test is the orange. So it's less than or equal to 4. So it has to contain this point. Here's my region. Very good. Now I'm going to draw the other one and test it. Here's the other place. This is my L1. So let's do L2. L2 is move the y, x minus 4 equals y. Okay, what does that mean? I start with the y-intercept, 1, 2, 3, 4, this way, that way. So the slope is 1, so that means up 1 over 1. Here's my thing. Let's draw. This time I'm going to draw a dotted line because it doesn't have an equal sign. Does it make sense? Now I have to do the shading. I'm going to do the shading with the blue. Let's try. This is my L2. I'm going to put 0, 0, test point, 0 minus 0, less than 4. Is that true? Yeah, that's true. So what does that mean? I have to shade the region that contains that. So how does that look like? So, sorry. It was like that, right? Now, this is my region. So I'm going to shade the region that contains that point, and that's going to be on this side. So let's go and do that. Does it make sense? All right. Now let's look. Where does the orange and the blue are intersecting? I can see it. They're intercepting. Here's my borderline. Here's my dotted borderline. And they are intercepting. They're on top of each other right here. What does that mean? That means all the points in the brown region are included in your solution set. Let's do one that has 3, so that's kind of a little bit difficult. And we're going to go a little bit deep. So let me get some colors there. I'll take some greens and things. Okay, so let me do L1, L2, L3. Now I'm going to try to put everything in slope-intercept form. So here we go. L1. I'm manipulating this. 6x minus 12 equals 2y. Let's divide everything by 2. I have y equals 3x minus 6. So let's draw that one. So minus 6 is my y-intercept, 1, 2, 3, 4, 5, 6. And my slope is 3, which is 3 over 1. So that means 1, 2, 3 over 1. And I'm going to go and I'm going to draw that. I lost my little ruler. And that one has equals, so I'm going to do a solid line. Okay, so that's my L1. Okay, now let's do L2. L2 is y equals 3. Y equals 3 means 1, 2, 3 here. And it's going to be equal, so I have to draw a solid line as well. This is my L2. And then I'm going to do L3, y equals negative x. y equals negative x is going to go down at 45 degrees. And since it has equal, I have to put a solid line. All right, here you go. This is my L3. Now I'm going to do some testing. Let's do the testing for L1. And I'm going to do that in green. So I'm going to test 0, 0 for green. So I'm going to go to my original equation. 6 times 0 minus 2 times 0. Is that less than or equal to 12? It sure looks like it. So which way am I going to shade that? The region that includes that. So I have to shade it. And since it's L1, I have to shade it this way with the boundary at L1. So let's do L2 in orange. Here's my L2. So I'm going to test 0, 0 again. Let's plug 0, 0 in this equation. How does that work? 0 minus 3, is that less than or equal to 0? It sure looks like it. So I have to shade the region that contains that point, which is this. Does it make sense? Now, I'm going to go check the blue. Y equals negative x. So let's put it in here. So I'm going to test 0, 0. Oops, I cannot test 0, 0 because this line goes through 0, 0. So I'm going to have to pick something else. I'm going to pick that one, which is 0, 3. So let me test that x for the blue. So I'm going to go 0, 3. I'm going to put from this equation, put 0 for x, put 3 for y. Is that greater or equal to 0? It sure looks like it. All right. So what am I going to do? So I have to shade the region that contains that point. And here's my borderline. So which way is it going to go? It's going to go this way. Now I look at the green and the orange and the blue, and what do I see? Where do they all overlap? Because this one is coupled with the and statement. So it has to be the overlap. So where's that going to happen? Right here. The brown region. Now, sometimes they may ask you, what are these A, B, and C are? I'll show you how to do that. So this is what you need to do. For A, A is the intersection of L3 and L2. Now L3 is this, and L2 is this. Can you solve that? Yes, that gives me y equals 3, and then that will give me x equals of negative 3. What does that mean? So this is going to be, this A is going to be negative 3, 3. It looks like I drew it okay. Let's look at B. So this one gives me, A is given by L3 and L2. So let's do B. For B, I'll look at where they overlap, which lines. That one is the intersection of L1 and L2. Do you see that? L1 and L2. Let's write those equations. L1 is 6x minus 2y equals 12. And L2 is y equals 3. All right, can I solve that one? Y equals 3, so put 3 in here, so you're going to end up 6x minus 6 equals 12. 6x equals 18. X equals 3. Very good. What does that mean? So this one is 3, 3. Good. Now I'm looking for the C. C is the intersection of L3 and L1. Okay, so let's do that. L3 and L1. What is L3? X equals y, negative y. What is L1? 6x minus 2y equals 12. Let's solve for y first. Instead of x, I'll put negative y. So that's going to be negative 6y minus 2y equals 12. Negative 8y equals 12. Y equals 12 over negative 8. Divide both sides by 4. Negative 3/4. So that's going to give me my C. All right. How am I going to get the x? That's going to be negative y, which is 3/4. Here it is. 3/4 and negative 3/4. Does it make sense? I think I made a mistake someplace. 12 divided by 4 is 3. 8 divided by 4 is 2. 3/2. Okay, so that makes a little bit more sense because it looks like it's 1.5. And this one is 3/2. So let's put that in there. Sorry about that. So let's label this a little better. 3/2 and negative 3/2. Now it makes sense. Very good. So this ends this section. And just try to practice. Keep in mind that if we were asked to do or statements, let me give you one example. For example, in the very first example that I did, it was x less than 2 and y greater than or equal to 5. It was like that, greater than or equal to 5. So you had this, and then x is less than 2. So this one is solid. That's y equals 5. And then x is less than or equal to 2. That's x equals 2. So it was to the left. The blue, I said, okay, well, when these two are in together with an and statement, the region that's applicable is where the overlap is, which is this. But in some books, they may ask you to do this. So keep that in mind. They may say x less than 2, y greater than or equal to 5. And they put or specifically. Okay, so how are you going to do that? So you start the same way. You do the same exact stage until the very end. So here's my y equals 5. Here's green. And x equals 2. Here's blue. All right. Now, the final answer, since this is put together with the or statement, what does that mean? Your solution set has to be in here or both. So what does that mean? It has to be here. It has to be here. It has to be here. The only place that's not there is that white area. So do you see the difference? This one is and, the orange is the answer. This one is or, this orange is the answer. So pay attention to that.